word efficiency in full. Okay, efficiency. Write the word efficiency in full. This one here is okay. Avoid that, because EFF could even mean effort. The reason why sometimes students are tempted to write EFF for efficiency is because the word efficiency begins with E and double F. But remember, that is not the only word that begins with EFF. Even effort begins with EFF. So if you write EFF, it could be interpreted for efficiency, but also effort. So let's learn how to write the correct symbol for efficiency. And if we're not writing this, write the word efficiency in full. So my dear friends, that is what we did last time. We introduced machines, we talked about those terms, and we got these explanations. So today, I want us to continue from there. We are going to look at some examples. How do we solve some problems in machines, okay, involving some of these terms here that we have looked at. And then you will be able to perform some simple calculations as far as these terms that we have discussed are concerned. So let's look at some examples. You can write this example somewhere in your notebook. I'm going to rub this side because we don't need it anymore. So I'll just write this, rub this. So we have examples. Please write this example down. Machine uses an effort of 400 Newton to raise a load of 600 Newton. Then calculate Roman 1, we have mechanical advantage. Then Roman 2 is velocity ratio. Velocity ratio. And then, okay, yeah, mechanical advantage, velocity ratio. Yes, so that's the example that I want us to begin with, that a machine uses an effort of 400 Newton to raise a load of 600 Newton. Then we want to calculate the mechanical advantage of the machine and the velocity ratio of the machine. Now, I need to draw your attention to something that is very important that we discussed. We said that from the definition of a machine, you are supposed to be able to use a smaller effort, okay? A machine should be such that you put in a small effort to overcome quite a bigger load. Because we are saying a machine is a device which makes work easy, right? So if it makes work easy, then I need to put in quite a smaller effort, okay, for it to be able to do quite a bigger load. That is why you can see here the effort which we are applying into this machine is 400 Newton, okay, and then the load which the machine is overcoming is 600 Newton. So we are saying a machine uses an effort of 400 Newton to raise a load of 600 Newton. Calculate, we need its mechanical advantage. Sorry, the velocity ratio, we are not going to calculate the velocity ratio because what we need to calculate the velocity ratio is not in there, but we are just calculating the mechanical advantage. Velocity ratio is in the It's in the next example. Okay? So read the information, be able to pick out what they've given. From here, if you look at this machine uses an effort of 400 Newton. So straight away they've given us effort is 400 Newton. Okay? Then this machine uses that effort to raise a load of 600 Newton. So we have the load is 600 Newton. Then we want to calculate the mechanical advantage. You remember the formula for calculating mechanical advantage? Yes, mechanical advantage is equal to load out of effort. So we shall say our MA is load out of effort. Okay? So what is the load? The load is 6 Newton. So we shall have 600 Newton rather. 600 Newton, then out of our effort, which is 400 Newton. Now, sometimes students are fond of substituting the units at each point. That is not necessary. You don't have to keep on writing 600 Newton, 400 Newton. Now, I am putting this here to re-echo what I mentioned last time, the reason why mechanical advantage has no unit. You remember? We said that there is an explanation that we gave for why mechanical advantage has no unit. So because the load is measured in newtons and the effort is also measured in newtons, this newton here ends up cancelling out with the other newton. And that is why at the end of the day, mechanical advantage is not going to have a newton. However, I'm not saying that you need to keep on substituting the units there. It is not necessary. I'm doing this for you if perhaps you missed the other previous lesson that we had where we explained why mechanical advantage has no unit. Are we together? So because this newton has cancelled out with that newton, the final answer you're going to have will have no unit. So these two zeros will as well cancel with those. You're having 6 out of 4. You can still divide this by 2. This is 3. By 2, this gives us 2. So when you divide 3 by 2, you get 1.5. Okay? So our mechanical advantage is 1.5. Are we together? Very good. Now, take note that this 1.5, we are not going to put any unit here because the units that maybe would have been there have already been cancelled out here. The newton, load is in newton, the effort is also in newton, so they end up cancelling, and therefore our mechanical advantage has no unit. Are we together? Very good. Now, that is the first example. So we are saying it is very important you read the question and understand, pick out the information that they've given. They've given us load, they've given us the effort, know the formula to use, okay? That's if I'm calculating mechanical advantage, I get the load and I divide it by the effort. If you do that, the calculation is really as simple as what you've seen there. Let's look at the example 2. I'm going to put example 2 right on the other side.